All right, welcome everybody to the second part of Unit 3, Lesson 2, Part B. So we're on the second part. We want to be able to find the slope, looking at slope-intercept form, and be able to calculate it. If we just have 2 points on a plane, we want to be able to find the slope between those points without having to actually graph it. So I'm going to use some white paper. It's a little easier to see here. Your paper's yellow. And we have our objective here, that students will identify the slope, okay, and the y-intercept. Okay, so why is that important? The y-intercept, if it's in slope-intercept form, the y-intercept is your starting point at 0, b. If we look at our equation for the line, that's this trailing number here, where you start at 0, b. on the graph. And we'll look at it in one of these examples right here. If I was going to graph this line here, let's say I'm going to start this graph at 0, -6. That's your y-intercept. That's where I start my graph. I could say b equals -6, but my point, my location start is 0 and -6. And then I need to know the slope. The slope is how my line moves. That's the movement of the line. And you can see it here as m, the number in front of x. The slope is always written as a fraction. Write it as a fraction. Now, it's also the slope by the letter m is going to be the rise of the line over the run. That's up or down, left or right, right or left. Another way to look at it is if it's going up and down, that's going to be the change in y. We're going to call it delta y over delta x. That's the change in y over the change in x. So we're going to be able to graph and interpret linear function using slope and y-intercept. And we have a lot of vocabulary here that we've already looked at. Please take a minute to pause the video at any time if you want to look at this. These notes will be available in the Google Classroom also. So now we're looking to look at what is this, the slope here. That's the slope, m. The slope is equal to 1 over 4. Now, if that's the rise, that's going to go up, because that's the rise, and this one's going to go right. So your line's going to go up 1, right 4, because that's your rise over the run. Okay, so what if so let's look at our starting point here is 0, 3 to start our graph. And then our slope in this situation is -5. Now that is a negative sloping line, but that's not written as a fraction. Remember, we got to write the slope as a fraction. So we'll rewrite this as -5 over +1, which means it goes down and right. Now that's positive. If you needed to rewrite that as +5 over -1, what changes? It goes up and left. Okay, here there's no number written at all, so we're going to put a number there. What number would we put? 0 doesn't make sense. I would get rid of it, so it's got to be a 1. So we have our starting point, start, because b is 5. We're going to start at 0, 5, +5. And then our slope, m, is going to equal -1 over 1. So this line then goes down and right. How else could I write that number? I could have written it as +1 over -1, and in that case it would go up and left. So let's take a look at what it might look like on your yellow paper. So that we did these 3 examples. You're going to go ahead and turn that over. And We're going to look at the what we call the slope formula. Okay, so we have this these 2 points in space. Here's the points here and here, and we know that to find the slope, it's the up or down part of it first. Okay, well, to go from these first x and y's, notice that the number is sub. It's the point is x, and then this little 1 here is a subscript. Okay, it's not a superscript because it's down below. It's not an exponent. Not an exponent. Okay, so, and the same thing with the y one. That just means that's the first pair. It's the first pair. It means it's the first pair of x and y. Now that's a little bit messy, so I'm going to get rid of that. It's a lot of mess here. Let's get rid of this. You don't have to get rid of it on your notes, but we're going to get it all cleaned up here. Okay. We have our x-axis and our y-axis. And here we have our x and y. Now what's happening here? We have this downward movement. It moves down. And how does this line move down? That's the y's. So how do you find the distance between two y's? You subtract to find the distance. y2 minus y1. This is the rise part of the line. And then the other part is the run part of the line. So we're going to go from here to here to the right. And that's your run part. And how do you find that? That's the x, the changes in x's. How do you find distance there? You subtract two numbers, x2 minus x1. That's your run. So now we have a formula to find slope without having to graph. You can now find slope without graphing. The problem is that you have to be really careful about your signs and adding and subtracting. It's a good idea to use a calculator. Now you have to push the buttons correctly, calculator, to use this equation. Now let's write the equation one more time. Slope is equal to y2 minus y1 over x2 minus x1. Now that's a lot of writing to do. We have a simplified method if you want to use it. We're going to use this triangle, and it's going to mean, the Greek name for it is delta, and it just means the change, or the subtraction, or subtract. So we're going to call it delta y over delta x. And now we have a way to find these coordinates here. All right, let's first off, notice that we have to label them as a pair together. These guys are together. That's an x and a y. So we're going to call this the first pair. We're going to call this one x sub 1, y sub 1. So this is our second pair over here, x sub 2, y sub 2. Now it's just a matter of putting them in the formula. And just put your finger on it. y2 is positive 4 minus negative 2. And here we have 5 minus, that was your x2. Now we got to go to x1. It's negative 3. I'm going to use this parentheses here because I can now plug it into the calculator. I would push 4 minus, okay, that's your minus right there, negative 2, and I get 6. And then I can do 5 minus negative 3. So I do 5 minus negative 3, and I get 8. Okay, so you can do it that way. You can get 6 over 8, and then we're going to reduce to its lowest. They both share a 2, so we're going to cross cancel. 2 goes into 6 3 times, into 8 4 times, so we get 3/4, and that's your final answer for the slope. Now remember, when you have two negatives right next to each other, you could also rewrite the two negatives as a plus, and that makes it really easy. 4 plus 2, because two negatives multiplying makes a positive 2. 5 plus 3. Okay, so you can do that for 5, and for example, E and D. Let's do one more together. Let's first start off. How do you start? X1, Y1, X2, Y2. So this is my first pair of X and Y, and my second pair of X and Y. I'm going to use the formula. Slope equals Y2 is negative 3 minus, because the equation has minus, and then 5, positive 5. And then X2 is 3 minus, and this is negative 6. Okay, so let's try it with the calculator first. Okay, let me reset. Negative 3 minus 5. It's not minus negative 5, it's just minus 5. Hit enter, you get negative 8. And here we have 3 minus negative 6 is positive 9. Now remember, you can change the two negatives into a plus. If you ever see two negatives next to each other, you can change it into a plus. But this has a slope of negative 8 over 9. You're going to do these ones on your own. But let's take a look at if we did this right. So let's graph E and F. So let's see. Point E is at negative 6, 5. And point F is at 3, negative 3. And let's see if we were able to graph that correctly. So, how do you find a coordinate? Okay, to find, these are locations on the coordinate plane, and this is a location. This is my x1, y1. So my x-coordinate from 0, 0 is negative 6, positive 5. Point E, negative 6, 5. And then my point F is 3. Remember, this is my x-coordinate and my y-coordinate. 3, negative 3. F. I connect the points, and I can check if my slope was correctly calculated. Okay, let's take a look here. It looks like to get from point E to point F, I travel down 1, 2, 3, 4, 5, 6, 7, 8. So I'm traveling down for my slope. The vertical change is minus 8. That's my y2 minus y1. Remember, we have x1, y1, x2, y2. So my changes in my y's from 5 to negative 3 was negative 8. And then my change from E to F, 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. That's positive 9. That's my changes in x's. So my slope was, remember, it's the rise over the run, It's negative 8 over 9. And that was a lot of work, but we can see that we get it correct without having to graph it? Yes. Okay. Good luck on the other two.